Okay. Hi everyone, welcome back to my YouTube channel, The Math Aficionado. Today's video is going to be a second part on the chapter number 3, which was discovering the fractions and the factors. Okay. So now we have covered 3 lessons. So we basically had 6 lessons as a part of this chapter. And the first 3 lessons we have covered in the part 1 of the video of the chapter 3. I'll put that in the cards below and you can refer to that video. Also, this is going to be our second part on the chapter number 3, and this is going to have the remaining 3 lessons of the chapter. Okay, now I'm just listing down all the lessons of the chapter number 3 again, and I'm going to cover the last 3 lessons of the chapter. Okay, so let's start. Now, this is your chapter number 3, which is discovering or understanding the fractions and factors. Right now, this chapter had basically 6 lessons. First lesson was monomials and addition and the subtraction of polynomials. Monomials and addition and subtraction of polynomials. Second lesson was powers and exponents. Third is multiplying. Polynomials and binomials. So these 3 lessons we have covered as the part 1 of the chapter number 3 video. Okay, now we are going to cover the remaining 3, which is number 4, that is factorization and prime numbers. Lesson number 5 is finding the greatest common factor. And lesson number 6 is finding the least common multiple. Finding the least common multiple, which is LCM. Right, so we are going to cover these as a part 2 of chapter number 3. This was your part 1 of chapter number 3. Clear? Okay, so let's start with lesson number 4, which is factorization and prime numbers. Okay, so we are going to start with lesson number 4, which is factorization and prime numbers. Okay, so first we'll talk about the factors, what exactly is a factor, then we'll come to see how do we perform the factorization. Okay, so what is factor basically? Factor is a number that is divisible by another number and where the quotient is an integer. Okay, for example, if I have to give you, so let's say if 18 is divided by 2, so what do we get? 9. So this 9 becomes your factor. Clear? So here what we did is we divided one number by another number and the quotient that comes, which is an integer, becomes your factor. Now suppose instead of getting an integer as a quotient, we get a decimal. If you divide 18 by 4, so we get 4.5, right? Now this is not a factor. Why? Because it is not an integer. Here the quotient is not an integer, right? That's why it is not a factor. Okay, so from the first case we can say that 2 is a factor of 18, right? Because the answer is integer, which is 9. But here we can say that 4 is not a factor of 18 because the answer is 4.5. Okay, not an integer. I hope that is clear now, right? Okay, now there are few thumb rules. So there are few thumb rules to figure out whether a number is a factor or not. To figure out whether a number is a factor or not. Okay, so now let's say if there is a number 2. So here this is a even number and this is always divisible by 2, right? Even number which is always divisible by 2, correct? So when we talk about 2, it is an even number and this is always divisible by 2. Similarly, if we have 3, now when it is the case of 3, so then the sum of the digits is divisible by 3. Sum of the digits is divisible by 3. Similarly, for 5, we can say if the last digit of the numerator is a 5 or 0, the number is divisible by 5. So if the last digit of the numerator is 5 or 0, then the number is divisible by 5. Okay, similarly for 6, we can say if the number is divisible by 2 and 3. If the number is divisible by 2 and 3. And for 10, finally, if the last digit of the numerator is 0, then the number is divisible by 10. If the last digit of numerator is 0, then the number is divisible by 10. So these are the few thumb rules to determine if the number is a factor or not, and you can remember these rules. Okay, we will be implementing these rules in the examples which we are going to take up next. Okay, so let's take few examples on this to understand this better. Now the first example that we have here is you have to determine whether 256 is divisible by 2, 3, 4, 5, 6 or 10. Okay, so we'll check one by one. We'll be applying those thumb rules that we just discussed. Okay, so when we divide 256 by 2, what do we get? We get 128, right? Now what was the rule of 2? That the even number which is always divisible by 2, right? Correct. So 256 is an even number. This is an even number. We can say that even number is always divisible by 2, right? So yes, this is a factor. Clear? So 2 is a factor of 256. 2 is a factor of, I hope that is clear now. Now let's come to the next. 256 divided by 3. Now when we take the case of 256 divided by 3, so what was the thumb rule corresponding to 3? Sum of the digits is Sum of the digits has to be divisible by 3. So what are the sum of the digits here? Sum of the digits are 2 plus 5 plus 6, which is 13, right? Is 13 divisible by 3? No. So here when you divide, you get 85.3, so it's no. Clear? Here it was yes. Okay. Why it is no? Because when we sum the digits of the given number, which is 256, we get 13, and that is not divisible by 3. And hence we can say that 3 is not a factor of 256. Clear? Now let's move to the next case. Next is 256 divided by 5. Now when it comes to 256 divided by 5, so what was rule of 5? If the last digit of the numerator is 5 or 0, then the number is divisible by 5. So is the last digit 5 or 0? If you check the last digit here, so it is 6, right? Not 5 or 0, right? So here it is again a no. Clear? Similarly, and even if you divide this, right, so you will get 51.2. You will get 51 point. Clear? That itself indicates that 5 is not the factor of. So 5 is not a factor of 256. Clear? Let's move to the next. Now we'll be dividing 256 by 6. Now when it comes to 256 divided by 6, what was the rule? What was the rule for the 6? If the number is divisible by 2 and 3. So if the number is divisible by 2 or 3. So now as we have seen that it was divisible by 2 but not divisible by 3. Correct? So since it is only divisible by 2 but not 3. Since this is divisible by 2 but not 3. So we can say that 256 is not divisible by 6. Okay, so even if you divide this, so you'll get 42.67. So that's it. That itself indicates that this is not a factor. Okay, so 6 is not factor of 256. Clear? Okay, let's move to next. Now 256 divided by 10. What was the rule of divisible by 10? So if the last digit of the numerator is 0, then the number is divisible by 10. So do we have the last digit as 0? Is not 0, right? Rather it is 6. So if the last digit is not 0, if the last digit is not 0, then we can say that it is not a factor, right? So I hope the things are clear now. So we have seen that 256 is only having one factor, which is 2, among all the factors that we discussed. Okay, and also this indicates that, okay, so this also clarifies all the thumb rules that we discussed before, right? Okay, now what exactly is prime number? So when we talk about prime numbers, what is prime number? So prime number is basically an integer greater than 1 that only has two factors. That only has two factors, which are 1 and the number itself. Okay, so what are those factors? 1 and the number itself. And what are the examples here? What are the examples of prime numbers? So 2, 3, 5, 7, 11, and so on. So now if you see these numbers, right? So these numbers only have two factors. One is 1 and another one is the number itself. By number itself, I mean to say, suppose if we are talking about 2, so the factors that it is going to have is 1 and 2. If we are talking about 3, so then the factors we are going to have for 3 is 1 and 3. Okay, but on the other case, when we talk about composite number, so that is an integer which is greater than 1 for sure, but that has more than two factors. For example, the number 4 has the factors 1, 2 and 4. So number 4 has 3 factors, 1, 2 and 4. Similarly, number 6 has 3 factors, which are 1, 2 and 3 and 6. Sorry, 4 factors is what we have for the number 6. Okay, so which are 1, 2, 3 and 6. So we can say that composite number is an integer which has more than 2 factors, unlike the prime numbers. Okay, now one more thing that we have to see is when we talk about composite numbers, so in the factors we can always express a composite number in the factors of prime numbers. So the factors that we have for the composite numbers are mostly prime numbers, factors of prime numbers. So as you can see above, that when we talked about the 4, right? So 1 and 2 were prime numbers. Sorry, 1 is not a prime number, only 2 is a prime number here. So when we talk about 4, so 2 was a prime numbers. Okay, so we can say that the composite number factors can also be prime numbers. Okay, as we have just seen the example of 4. Similarly for 6, when we talk about, so 2 and 3 are the prime numbers, right? Which are the factors for the 6, right? Now we are going to take the example of a bigger number. Let's take 64. Now we know that 64 can be written as 8 times 8, right? Now how do we basically break down a bigger number into or to its corresponding prime factors? So what we do is first we write the bigger factors. So here in this case 64 has the biggest factor as 8. Now we break down those factors into sub factors, or you can say smaller factors. So 8 has a factors of 4 and 2. Similarly here also it is 4 and 2, right? Now again we further break down the factors. So 4 will be further written as 2 times 2. This is already 2. And this is also 2 times 2. And this is already 2. So how many 2's are repeating? 3, 4, 5, 6. So we can write 64 as 2 to the 6. Okay. So this is how we write a bigger number as the multiplication of its respective prime factors. What is 2 here? 2 is a prime number, right? So we have broken down a bigger number into its respective prime factorization. Here we'll take one last example and then we'll move further. So the last example that we have here in the lesson is 12x cube y cube. Now this is a term that we are supposed to break down into its factors. Okay, so we basically have to factorize this expression. So how do we do that? So now first we'll be breaking down 12. So 12 can be written as 4 times 3, and this 4 will be written as 2 times 2, and this remains as 3. Right? Now this is basically x times x times x, and this is also basically y times y times y. So what are the factors here? 2 times 2 times 3 times x times x times x times y times y times y. So these are the factorization of 12x cube y cube. Clear? So this is how we factorize this expression. I hope this makes sense, and this was about your lesson number 4 of chapter number 3. Okay, and this was all about factorization and the prime numbers. Now let's move to lesson number 5. What was lesson number 5 in the first place? Let's see. So your lesson number 5 was finding the greatest common factor, right? So lesson number 5 was finding the greatest common factor. So let's start with lesson number 5, finding the greatest common factor. Okay, so what exactly is GCF, or you can say the greatest common factor? What is GCF basically? So greatest common factor is exactly as it sounds, the greatest factors of the 2 or more numbers. Greatest factor of 2 or more numbers. So this is how we define the greatest common factor. Let's take an example. Okay, so basically now you have to find the common factors of number 60 and 30. So you have two numbers 60 and 30, and you're supposed to find the common factors of 60 and 30. How do we do that? So what we are going to do is we are going to individually find the respective factors. Okay, so 60, now we know that 60 can be written as 6 times 10, right? 6 can be written as 2 times 3, and 10 can be written as 2 times 5, right? So can we write this as 5 times 3 times 2 times 2? I've sorted them in the descending order. Similarly, 30 is 3 times 10. 10 can be written as 2 times 5. So this will be 5 times 3 times 2, correct? Now, if you see that these are the, now if you see here, these are the common factors here, right? So 5, 3 and 2 acts as a common factors in this case, right? So when we combine them, so 5 times 3 times 2, so that is 30. So 30 becomes the common factor, or you can say the greatest common for numbers 30 and 60. Okay, so the greatest common factor for the numbers 30 and 60 is 30. So this is how you find the greatest common factors. Clear? Okay. Now we can also find the greatest common factors if you don't have both the numbers as numbers exactly. You can also find the greatest common factor when you have the case of one number and a variable. Or you can say if you have both numbers and variables. Let's say if you have two expressions which has both numbers and variables, then also you can find the GCF. Let's see how do we do that. Okay, so finding the greatest common factor if you have both numbers. So previous case was only numbers, but here we have both numbers and variables. Okay, so let's see how do we find the GCF when we both have numbers as well as variables. So the example here is find the greatest common factor for 36x square y, which is the first expression, and 16xy, which is your second expression. Okay, so now what we are going to do is we'll be factorizing the numbers, right, and identify all the common factors. Right, and then we will be, to get the GCF, we'll be multiplying all the factors. We'll be multiplying all the common factors. Let's see how do we do that. So the first expression that we had was 36x squared y. The second one is 16xy, right? Now, if you see this 36, so this can be written as 36 can be written as 4 times 9, 4 can be written as 2 times 2, and 9 can be written as 3 times 3. So can we write it as 2 times 2 times 3 times 3 times, and then we have x square y. So x square is x times x, and this is y. So it will be x times y. Correct? Similarly, for this one, when we write 16, so 16 is 4 times 4, and this is 2 times 2 and 2 times 2. So it can be written as 2 times 2 times 2 times 2, and then you have x times y. So this is common. This is also common, right? What else is common? This is common, and this is common. Yes. So what do we have the common factors as? Yes. So what are the common factors? 2 times, so GCF here is 2 times x times y, which is 4xy. Clear? So this is how we find the GCF of a situation when you have both numbers as well as variables. Now what is ratio? Next we are talking about is ratio. So ratio is an expression that tells us the quotient of two numbers. So basically when you divide two numbers and you get the quotient, right, that's what the ratio is. For example, 3 to 4, so that can be written as 3:4. Okay, and how does it come? So when you divide 3 by 4. Okay, so this is how you represent the ratio. So this becomes your ratio, basically ratio of 3 to 4. Now why did I talk about ratio? Because ratio has a significance in terms of finding the GCF. So what is the significance of ratio in GCF? So you can simplify your ratio by finding the GCF. So it becomes easy to simplify a ratio when you find the GCF. Okay, for example, let's say 2000 divided by 1500. Now this is your ratio, right? How do we simplify this ratio? By making use of GCF is what we are discussing now. So what we are going to do is we are going to factorize all the numbers which are 2000 and 1500 in this case, and find all the common factors. So when I find the common factors for 2000 and 1500, so let's first find the factors of 2000. So 2000 can be written as 40 times 50. 40 can be written as 4 times 10. This is 5 times 10. 10 can be written as, sorry, this is 2 times 2 and this is 2 times 5. This is 2 times 5, right? And this is 5 as it is. So we can write it as 2 times 2 times 2 times 2 times 5 times 5 times 5. Yes. Similarly, for 1500, when I talk about 1500, so this is 30 times 50. This is 3 times 10. This is 5 times 10. This is 2 times 5 and this is again 2 times 5. 3, 5. So we can write it as 2 times 2 times 3 times 5 times 5 times 5, right? So what are common here? This is common, this is common, then these three are common, correct? So the GCF here is 2 times 2 times 5 times 5 times 5, which is 4 times 5, which is 20. 20 times 25 is 500. This is 500. So the GCF here is 500. Now, once we get the GCF, now we are going to simplify the ratio. So since we know that GCF is the greatest common factor, right, for both the numerator, which was 2000 in this case, and denominator, which was 1500, right? So we can divide both the numerator and denominator by the GCF that we just figured out, that is 500, to produce a simplified fraction. To produce a simplified let's see how do we do that. So we had 2000 and here we had 1500. Now we are going to divide both numerator and denominator by the GCF, so you get 4 over 3. That's how you figure out a simplified fraction. I hope that makes sense. So that's your ratio significance in terms of GCF, or in finding the GCF. Clear? Now I'm going to take the last example of finding the GCF of two expressions, which are 24x cube and 56x cube. So when I talk about 24x cube and 56x cube, now 24 can be written as 3 times 8. 8 can be written as 2 times 4. Similarly for 56, I can write it as 7 times 8. 8 can be written as 2 times 4, and 4 can be further written as 2 times 2. So this is 2 times 2 times 2 times 7. And then we have x times x times x. What is common here? 2 is common. Then we have 3x's as common, right? So the GCF here is 2 times x times x times x, which is 2x cube. Okay, so the GCF here becomes 2 times x cube. Now here sorry, here I forgot to split this one to 2 times 2. Okay, so this can be rewritten as this is 2 times 3 times, sorry, 2 times 2 times 2 times 3. Now here so we have these three as common, right? So we can write it here as 2 times 2 times 2. So this simplifies to 8x cube. So this simplifies to, this is 8 and this is x cube. Okay, so your GCF here in this case is 8x cube. I hope that is clear. This was all about lesson number 5, which is finding the greatest common factor. Okay, so I hope the concept that we discussed here is clear to you. Okay, let's cover the last and the final lesson of this chapter, which is lesson number 6, and that is finding the least common multiple. Okay, so finding the least common multiple. So this is your final lesson of the chapter number 3. Now when we talk about LCM, which is your least common multiple, so this is the smallest positive integers, that is a multiple of two integers x and y. When I say a multiple, so multiple is a product of number. A multiple is a product of a number if two numbers has one or more multiples. In common, then they are called common multiples. Okay, so when a multiple is a product of number. If two numbers have one or more multiples in common, then they are called as common multiples. Now LCM must be determined before two fractions can be added or subtracted. So LCM needs to be determined before adding or subtracting two fractions. Okay, I'll give the example here and that will make it more clear. 8 divided by 12, this is your first fraction, and then you have the second fraction as 2 over 6. Okay, now when it comes to what did we study about the LCM, so this is the smallest positive integer, the smallest positive integers, that is a multiple of two integers, which is a multiple of two integers x and y. What is a multiple here? So we have defined a multiple also. It is a product of a number. If two numbers has one or more multiples in common, then they are known as common multiples. Okay, so from this example we can see 12 can be written as 12 is 4 times 3. 4 can be written as 2 times 2, so it is 2 times 2 times 3. Similarly 6 is 2 times 3. 6 is 2 times 3, right? Now here the LCM will become this thing, which is 2 times 2 times 3, which is 12. Okay, so LCM here is 2 times 2 times 3. Now, how do we basically add these two fractions? So first fraction is 8 over 12, right? Now we know that the LCM is 12. So we'll write this as 8 over 12 because we have the LCM in the denominator, right? But when it comes to another fraction, which is 2 over 6, now here we have 6, which is not 12, right? So we will have to somehow convert this denominator to the least common multiple, which is 12. So what we will be doing is we'll be multiplying and dividing by 2. So I'm multiplying and divided by 2 in both the numerator and denominator. So this becomes 4 over 12. Now you see this is your LCM, right? This was your LCM. Now once you get the same denominator, which is basically your LCM, then you add the fractions. So now you can easily add the fractions. Okay, so 12 becomes your common denominator, and in the numerator also you have 12, and this becomes 1. Clear? So this is how you add the fractions. We'll see one more example, which is your last example in this lesson. So example is 2 over 9 plus 3 over 6. 2 over 9 plus 3 over 6. Now here, what is the LCM? Let's see. So 9 can be written as 3 times 3, and 6 can be written as 2 times 3. Yes. So 9 is 3 times 3 and 6 is 2 times 3. Now what is the least common multiple here? So LCM here is, so what is common here? 1 is 3, 1 is 2, right? And another one is 3. So this will be 2 times 3 times 3, which is 80. Okay, so now since when it comes to two fractions, so first one is 2 over 9. Now we don't have LCM here, right, in the denominator, so we'll be multiplying and dividing by 2. So this will give you 4 over 18. Now you see that we get the LCM in the denominator, right? Similarly, for the next one, which is 3 over 6, now we don't have LCM in the denominator, so what we are going to do is we'll multiply and divide by 3 so that we get 18 in the denominator. So this is 9 over 18. Now you see this becomes the LCM, right? Now you can add them. So this becomes 18 as a common denominator and 13 in the numerator, right? So you get the answer as 13 over. This is how you add the fractions by making use of the LCM. Clear? So this was all about finding the least common multiple and how do we use this concept in adding the fractions. Okay, so I hope the concepts that we discussed in the part 2 of this chapter number 3 is clear to you. This was all for today. If you found this video helpful, please don't forget to like, share and subscribe to my channel. The support motivates me in keep creating these content with love and dedication. So I would love to hear your thoughts in the comment section. Please let me know. Also, kindly let me know the suggestions for the improvement. So thank you so much. Bye.